Well, hello everybody. We're going to talk about finding side lengths in 45, 45, and 90 and 35, 30, 60, 90 triangles. This is, I would pause the video and write this down. Basically what we're saying is in a 45, 45, 90 triangle, these guys, it's an isosceles triangle, so the two legs are the same length, and so then whatever those lengths are, we end up with the hypotenuse equaling the leg length times square root of 2. And so I will give you an example of this if I draw one over here. So we have this angle is 45, this angle is 45, and a 90 degree here. So then when I see 45 and 45, I know the two legs are the same. So let's just make this guy 5, that one 5, and we're trying to find the hypotenuse. So going through, this is a shortcut up here for the Pythagorean theorem, but sometimes they don't give you enough information to be able to do Pythagorean theorem on it. So this is what you'd end up doing, these shortcuts, and I'll show you how it applies in just a second. But I'm going to show you how this shortcut happens. All right, so I've got these two guys right here. I've got 5 and 5. So I say 5 squared plus 5 squared are my two legs. That'll equal a hypotenuse squared. Well, 5 squared is 25. And that equals x squared. If I combine those two guys together, I get 50 equals x squared. Then I take the square root of both sides, so the square root of 50 is equal to x. And so 50 came from the fact that we added two 25s together, so it's 50 is the same as this underneath the square root. It's 25 times 2. And so then if I take the square, I can then break this into a multiplication problem where these are both square roots, because that's a property that we have for square roots. So the square root of 25 times the square root of 2. Well, the square root of 25 is 5, so it is 5 root 2 is the length of the hypotenuse. And that's what they're telling me would happen up here. If I know the two legs length and then I multiply the leg length by root 2, I would end up with a hypotenuse length. All right, and so that's how this works. That's how these guys apply. So let's try a couple examples here. In this first example, we're looking for the hypotenuse, and since this is 45 and that one's 90, I know this angle is 45 degrees, and so that side being 45 degrees, that would make this an isosceles triangle. So then I get 11 squared plus 11 squared equals x squared. And I could just go through and say, oh, well, if this leg is 11, then this guy by my shortcut is 11 root 2. Well, that's what will happen down here. I get 121 plus 121 equals x squared. 242 equals x squared. Square root of 242 is x. And then what ends up happening with this guy is that to get to 242, I did 2 times 121. And so I can take the square root of 2, multiply it by the square root of 121. That's the same value. And so the square root of 121 is 11 root 2. So the shortcut saves us a lot of steps along the way. In this one, they told us the hypotenuse. So basically, in our shortcut is if we know the short leg, so over here, if I know the leg, oops, let's try this again. Let's go back over here. All right, so for this guy, what you need to know is that the leg is equal to whatever it is, and is equal to x, and then the hypotenuse is x times root 2. All right, so in this case, they gave me the hypotenuse. So what I can do is say, oh, well, 9 is the hypotenuse, and I got to set that equal to x root 2 because that's what it would be equal to. If I then solve for x by dividing by root 2 on both sides, x would be 9 divided by root 2, and that comes out to be 9 divided by root 2 is about 6.36, and that's the length of the side, 6.36. And so if I square this and add it to itself again, and then combine them together by adding, I would end up with that. And so this right here is what we need to remember when we're doing these problems, just putting in what you know and what you don't know. All right, we'll try it again. We'll do it again in just a minute with a different type of triangle. All right, so then in a 30, 60, 90 triangle, a 30, 60, 90 triangle comes from an equilateral triangle, and I know this does not look anything like an equilateral triangle, but if I have an equilateral triangle, all the sides are 60. if I was to cut this equilateral triangle in half, I'd get a 90-degree angle there, which means this top angle is 30. So when I cut it in half, if I kind of ignore one of the sides, if this side is x, all right, that would be this piece right here, then this side would have to be twice x because these guys were an equilateral triangle to begin with. So now I'm looking at this 30, 60, 90 triangle here, and I'm going to make it nice and straight lines here. This 30, 60, 90 triangle. And so what we have is basically the fact that in this 30, 60, 90 triangle, that if the short leg is x and this longer hypotenuse is 2x because it's double the length of the 60 that we had there. Sorry, I'm just filling in my triangle again. So it's double the length. If I did Pythagorean theorem, I could find out what this side is. I'll call it y for right now. And so I've got x squared plus y squared equals 2x squared. And so x squared plus y squared equals 4x squared. When I square those, subtract the x squared across the equal sign. Y squared is equal to 3x squared. And then if I take the square root of both sides, y comes out to be x times root 3. And that's because if I take the square root of x squared, I get x, and then the 3 is just a root 3, so that's where this guy is coming from right there. So you need to have these down because these are the shortcuts when I'm given this type of triangle. So let's go over here and let's write it down here. So the short leg is x, typically. Well, I mean, that's what we're calling it. The long leg would be x times root 3, and the hypotenuse is 2x. That's what I gave you on the previous page. Okay, so that's for any 30, 60, 90 triangle. And so that's the things you need to know. We may not be able to go through Pythagorean theorem to solve it, so we just kind of need to remember these shortcuts. So in this case here, I gave you that the long leg, because I can see that it's opposite the 60-degree angle, the long leg is 8. And so in that case, I'd use this equation to find out what x is, which would give me the short leg. So what I'm going to do is I'm going to say 8 equals x root 3. And if I divide by root 3 on both sides, that's what x is. X is 8 divided by root 3, or if I do that on a calculator, we end up with 4.61. So that is 4.61. So that's the length of the short leg over here, 4.61. And then what does it say to do with the x value to get the hypotenuse? Well, to get this y is going to be equal to twice the short leg because it's the hypotenuse, the side opposite the right angle. So then if I double that, y is going to equal 9.22. 9.22. All right, and so that's the length of the hypotenuse. Again, over here, that's probably the hardest case scenario when they give you the long leg that doesn't have a square root of 3 in it. You got to do this division and whatnot. Over here, using these same properties, this time, what side did they give me? Well, they gave me the side opposite the right angle. So they gave me the hypotenuse is equal to 2x. So 14 equals 2x. If I divide by 2, then x, the short leg, is 7. That's great. So that gives me the short leg. So now if the short leg is 7, it says that I take the long leg times root 3, take the x times root 3 to get the long leg. Well, that's what y is. So y is x times root 3. So y is going to equal 7 root 3. And if you need to go to a decimal, you go to a decimal for that. All right. And so we will practice a few more of these in class as well.